Digital modulation. See, we are dealing with wires or wireless channels. Now these channels, they carry analog signals. Okay, this can be done using voltage, light intensity, sound intensity, so we can vary it, and then these wires and wireless channels, they can carry the analog signal. So if you want to send the signals on this analog channel, for example, you have bits, you have to send it on wire. So how to send these bits on the wire? Wire will have, because this is an electrical component, it will have a voltage, it can have ampere. If fiber is there, it can be light. Okay, so the only idea is to vary all these, and with different voltage, different bits can be sent. So to send a digital information, that is 0, 1, 1, 0, like this kind of thing, this kind of binary digits or bits, in order to send this digital information, we must devise analog signals. Those can represent these bits. For example, we have multiple computers. One computer is sending, say, 1011, and the other also has to get 1011. But the channel or the mode are analog. So how to represent this 1011 in terms of sending, so that the wire can take this 1011 and the other computer can understand that 1011 has come. So this exact process, the process of converting between these bits and signals, is called digital modulation. Okay? Let me tell you again. The process of converting the bits, digital bits, binary digits into signals is called digital modulation. So there are various schemes. There are various schemes that converts these bits into signal. And these are called baseband transmission. Baseband transmission. I told you about baseband signals. So the schemes that converts bits into signal, baseband transmission. And what is the basic thing? The signal here will occupy frequencies from 0 to certain maximum signaling rate. Let us write it as max. This is the baseband signal. Very common to the wires, coaxial cable, twisted pair. Very common baseband transmission for the wires. But there are certain schemes, rather than voltage intensity or sound, light or sound, it can regulate the amplitude, phase and frequency. See, any signal, it will have some amplitude like this. It will have some angle, that is the phase, and number of oscillation, that is the frequency. So there are certain schemes that can regulate, that can modulate, that can change the amplitude, phase and frequency of a carrier signal to convey bits. And these are called passband transmission. What are these called? Passband transmission. You understood the difference between baseband transmission and passband transmission? Okay. So these are the schemes where we are varying the amplitude, phase and frequency of the carrier signal in order to represent the bit. In this passband or band pass transmission, the signal will occupy a band of frequency around a central frequency, around the frequency, and this frequency will be of the carrier signal, right? This is the central frequency I am talking about, passband transmission. And this is very common for the wireless and the optical channels, where the signals has to reside in a given frequency band. There is a particular frequency band and the signals have to reside inside this. There is one more concept, multiplexing. Now, there are multiple people who want to use this channel or the road, say. When all these three can go together, so the channels or the road, those share or they are shared by multiple signals. Here we are taking the analogy of people. The channels are shared by multiple signals. This is called multiplexing.